Okay, just a few things left here on Matplotlib, the Matplotlib tutorial. So we can control the spacing of the we can control the space between the labels and the axes. So I think the best way is just to see this straight away. So what I set here was the X-tick major pad and the Y-tick major pad, and then the X-axis label pad and the Y-axis label pad. So let's see if I can generate this so you can see. Yeah. So the X-tick major pad is this distance here. So 20 is a large value, so these are highly offset, whereas over here it's only offset by 5. And then we have the X-axis label pad is the distance between the tick labels and the axis label. And here it's set to 5, and here it's set to 20. So you can see how that affects it. But by default, these are 3 or so. Now, there's a few different ways you can affect how things are saved. So sometimes when you save a figure, things get cropped, and there's one way to do that is by adjusting the subplots before you save the figure, so we can kind of readjust how things are positioned in the figure to make sure that they don't get cropped when we export it. We also have this ability to plot grid lines. So this is the way that we can do this is by generating the plot and then on an axis, and then on that same axis we use this grid method and set that equal to true, or providing extra details. So we can specify what the color is, what the transparency or alpha is, what style or width. There's a lot of customizability that we can use here. Same thing is we can change the color of the spines, or we can turn off certain spines, so we can have a lot of control over that. Another one that might be useful to you is plotting twin axes. So here we're going to plot. We're going to have 2 separate y-axes and the same x-axis, so it's going to be called twin x. So we're going to create, we're going to use subplots, and that's going to create axis 1, and we're going to plot to axis 1. Then we're going to use this twin x method on axis 1 to create a second axis and plot onto that. So for example, if you wanted to show area on this y-axis and volume on this other right side y-axis, you can do that. So these are effectively 2 plots that are overlaid, sharing the same y-axis. Excuse me, sharing the same x-axis. We can also change where the intercept is. So if you have negative data in these other quadrants, we can set the position of these axes to be at different places, in particular at 0. So even though the range of the data goes into the negative, the axes are still at 0. And then we're going to just cover quickly a bunch of other plot styles. I just want you to know these are available, and depending on what you're doing, it might be useful. So here's 4 examples. So and again, these are subplots. So instead of saying n rows, n columns, we're saying 1 and 4, and it figures that out. And then we're plotting to each of these 4 axes, we're using a different style of plot. So a scatter plot, a step plot, a bar plot, and a fill between plot. And these kind of work the way that you would expect. So you have a scatter plot, a step plot, a bar plot, and a fill between plot. We can also generate polar plot, and that has its own syntax, but it's depending on what you're doing might be useful. And then another really useful one is a histogram. So this comes up a lot in data science. So we can just use this function hist, and we can either just provide the array and it will use default parameters with like 10 bins and make this histogram, or we can also specify the number of bins. We can also make a cumulative histogram where we're going from 0% of the values all the way to 100% of the values, and we can set limits and those kind of things. We'll see some other ways to do that a bit later with Seaborn. We can also annotate plots. So here we've created this plot of 2 different series. We can actually combine. This is X and Y, and this is another X and Y in the same plot if we wanted to. This doesn't work as well with the labels, but the key point here is that we're annotating the plot with text. So we can specify a font size, a color, and then this is the X position and the Y position of the text, and this is the actual text itself. So we're using a LaTeX formatting here, and we can also control the horizontal alignment. So this is the X and Y position of I believe the lower left-hand part of the plot, but we can change that by changing the horizontal alignment and the vertical alignment. So we can make it so that this piece of text is centered on these coordinates rather than on one corner, just to get exactly everything aligned. Let's say you want to get your text aligned just over your data point. This allows you to do that. Also, we'll see ways that we can really spice up the canvas by adding lots of different subplots. So the standard subplot would be just like this, where we have a 2x3 subplot, but we can use these col span and row span options and this subplot to grid method to create much more detailed subplots if you want. And what I've done here is just showing you that for I can loop through or do a for loop through each of these 5 axes and then just plot X and Y, so you can actually see what it looks like when there's data in there. We can use this grid spec function to have a lot more control over how we can plot multiple things and they sort of refer to each other. We can also add axes. We saw this earlier at the beginning, so we can add axes at various positions and we can plot to those axes. So for example, if we have a main axis and we want to add something to that, we can use this add axes method. Finally, there's a lot of options with color maps and contour figures. If you're using potentially like an oceanography, you might be wanting to show gradients in oceanographic parameters, for example. So we're just gonna, this is just to show you an example. So we can do a 2D array with pseudo color using this using this color bar function. We can display an image on the axes using this IMShow function. We can show contours using this contour function. And we can also generate 3D figures if need be. So this is just an example function that or an example, a mathematical function that we are viewing in 3 dimensions. But you can see that there's a lot of options for how we render these. You can render them with color maps or with a mesh grid, or with wireframe, or with projections on the edges of the plot. We can also change the viewing angle with view init. So for example, we can show this sort of more default angle, or we can change the angle and look at it from the top. So there's a lot of extra functionality for both 2D and 3D plotting, with a lot of customizability. It really depends on what you're doing and what you want to focus on. If you're familiar with MATLAB, a lot of the stuff should be pretty familiar, should be pretty similar to what you've done with MATLAB. The nice thing about Matplotlib is it's all open source, so it's free. And what we'll see next is how we can, well, first I'll point out that there's a bunch of resources here for Matplotlib. There's a nice gallery. I'll click on this briefly. So you can go to this gallery and kind of look for what you're trying to do. And you say, oh yeah, I want to do multiple histograms, and it will show you how to make a plot just like this. In fact, you can copy and paste this text into your notebook and it will work, and you don't need this plt.show because we're using the notebooks, and it will automatically show it with the Matplotlib inline. But yeah, you can go to this this gallery and just kind of figure out what you want to do and start from there, or just Google, like, how do I make this kind of plot in Matplotlib. So that is it for lesson 13, and we'll take a quick break and then dig into lesson 14.